Mr. Silbaugh here, and this is my take on Unit 10, Lesson 8. All right, just as a forewarning, today is going to get very technical. There will be some math involved, and there's going to be a lot of behind-the-scenes stuff. That being said, take breaks if you need to, because this is going to be rather long. And also, you know, take a moment, research it if you need to, if you're not understanding it, ask for help from me if you need help, and just, take it one step at a time, because a lot of this is going to be very technical. And the thing is that you have to remember is I am just introducing you to these concepts, okay? You should be familiar with them, but you don't necessarily need to exactly know the individual functions and how they work behind the scenes, okay? It is just information you need to be aware of, especially if you continue on in web design, or if you decide to go into more computer science in the future. You do need to be aware of some of these issues and some of these things that we're going to talk about. So let's go ahead and get started. We're talking about back-end issues today in the first half of this lesson, and then the second half, because I combined lessons today, is we're going to be talking about download speeds, which there's going to be some math involved, but it's really interesting how we do it. All right, let's go ahead and get started. Back-end issues, okay? We talked about front-end issues. Those are what you see on the page. The back-end issues are the stuff you don't see, like the server connections, database issues, things of that nature. So server resources that collect and store user information are called the back end of a website, okay? Because your web documents are communicated over the network, they need to work correctly and they need to be able to function. If they can't function, then your web page is not going to show up because the server won't be able to process it. First thing we'll talk about is database connectivity, okay? So as you know, and as you've learned, websites do more than just showing text, posting images, and providing access to documents. A fully functional website is going to have databases, okay? Databases allow for customers to access information and to search for it, and they can allow companies to retrieve customer information and to save it if they need to access it later. All right, there are four main types of databases. The first is called a flat file database. This is information stored in a single table. Often it's just a text file. These are names, addresses, emails, and phone numbers. They're flat files, okay? Imagine also if you took like a napkin and started writing down people's contact information. That's a flat file, okay? It's just there. There's no way to sort it. It's just there, okay? Next is non-relational. The information is stored statically. It can be searched, like you could put it into a document, but you can search for stuff, but you can't sort it, you can't organize it, and you can't put it into another database, okay? It's like it's there. It's a much longer file than a flat file, but there's no way to like really actively store it and sort the information. However, relational, the information can be sorted and it can be altered and it can be placed in another database. You can place multiple information into different databases. That's the one we're going to talk about the most. And then object-oriented. This is a new form with capabilities of relational databases, but they have greater storage and they have greater search efficiency. Object-oriented will probably take off in the next few years. Next is relational databases. This is what we're going to talk about. Information is stored in tables in a relational database. The tables contain fields that allow the data to be cross-referenced and then joined, okay? Think of it like this. You have your information that you provide in the form, and that information gets sorted accordingly in a database. Now that that information has been stored, it can be cross-referenced, it can be looked at, it can be sorted. Like, there's a lot more you can do here. You can define the categories and the descriptions of the tables, like what each column means, so on and so forth. And the information can be added or deleted. So for example, when you search a website like Amazon or eBay, you're really using a relational database because it is their inventory. And let's say you search for something. Let's say you search for, of course, we'll go with cat toys. Let's say you search for cat toys, okay? It's not going to give me dog toys. It's not going to give me parakeet toys. It's going to give me just cat toys. Although, depending, it may give me other types of toys for other animals. That's on Amazon because of the way that the product was described, but that's something completely beyond this. This is saying that when you search it, you can narrow it down. Like, say I want it under $10, okay? Say I want it with free shipping with Prime. I'm able to narrow that down, and that's exactly what a relational database does. It allows for people to search very effectively, and it allows them to narrow down what they're looking for based upon the categories that Amazon has described it as. A relational database can be a single database or of a single file, or it can be spread amongst multiple database servers, like if there's more than one server. I would imagine someone like Amazon has multiple databases because they have one for like customer information, they have one for all of their different products, they have one for their like ebooks, probably, like just speculating. I would have to research more, but it would make sense. After you set up your relational database, you can access information in many ways. So for example, like you could create an alphabetical list of names, sort by ID number, ages, prices, etc. The text uses the example of like employees, like you could search by their last name, or their ID number, or their age, so on and so forth. You could go beyond, okay? Some of the database vendors, they include it in the text and they provide the websites. I'm not going to do that here. If you're really curious, you could do so on your own. Oracle is one, IBM, Microsoft, MySQL, and PostgreSQL is another. Those are the major ones that people use, and of course there are others, but those are the ones that the text provides, and those are some of the more major database vendors. All right, next we're going to talk about structured query language, SQL. Before I begin this is rather technical, and you don't need to know about it. Well, you need to know about it, but you don't need to know the ins and outs of it. You just need to know what it is, what it does, and that's about it. If you are curious, because database construction is a very in-demand field in computer science, that's, being able to do this is important. We don't talk about databases we talk about databases in this class, but we don't really construct them. If you take my Computer 3 class in the future, we do talk about using Microsoft Access, which is a database program, but nothing like what SQL is, okay? But if you're curious, you can take my Computer 3 class. We'll talk about databases more in depth. So in SQL, after you've created your few data tables, you can query them, search them to obtain information. If you want to search a relational database, you would use what's called SQL. This is a language used to create and maintain high-performance corporate databases. Essentially, SQL is used to obtain information. You search, and you can find information in relational databases. SQL is essentially the programming language for you to search, okay? You can create a web page that allows users to conduct queries through the page, which is very important, especially if you have like a shop. You want users to be able to search your inventory and find things quickly. You would program the web server to access the server-side application by using SQL. Okay, this one is also rather technical. I had to pause for a minute and think about this over before I presented it. The way that you connect to a database. You can connect to a database file by using two ways. The Microsoft Open Database Connectivity, ODBC, or the Java Database Connectivity, JDBC. Okay. ODBC is used to allow an OS to register a database. It supports SQL and all major database vendors. Once registered, the OS and its components can read and update a database. This was developed by Microsoft and is used only in Microsoft. Okay. Microsoft Open Database Connectivity It has Microsoft in the name, only used for Microsoft. However, JDBC is made by Sun Microsystems, the same people who made Java, and it's not limited to Microsoft systems. Okay, it allows connectivity between Java and a range of databases. It supports all major vendors and SQL. The things that you need to know about these is there are two different types of database connection methods. Okay, these are the ways that the database connects to the server. All right. ODBC is only used for Microsoft, and JDBC can be used for Microsoft and any other operating system. Okay, that's really what you need to know here. All right, don't stress yourself out over this part. Like I said, this is very technical, and the text just wants you to know about it. That's it. Okay. Lastly is indexing and cataloging. This is another feature for databases. Indexing is when the information is essentially tabbed and sorted by category, and it allows for easier navigation. Indexing is essentially that, it's categorized and you can search. Think of like an index in a book. It's labeled by the different categories, and then you could find what you need based upon that. Same thing works with a database. You can search by different categories directly. Catalogs can contain a collection of linked internet addresses that help users search for information in a more targeted way. Catalogs are essentially a large search ability. More complex sites can provide internal search engines, and users can conduct searches for site elements that way. Again, don't need to know how this works in and out, just need to know about it. All right. Now let's get into some really technical stuff. Bandwidth and download time. Okay, fair warning, there is math ahead, and you will have to do some math today. But it's not exactly hard math. You just need to know some conversion factors. All right, HTML pages are rather small, and they're easy to load over a network. Okay, we know this. HTML pages are very tiny. They're just text files that, once they're processed, create these nicely designed web pages. However, as we know, websites usually contain more than just text files. They contain images, CSS, JavaScript files, resources, and more. Okay? In order to display, the browser must have access to these resources as well. Remember, when we create our web page, we are essentially storing all of our files into a nice big file folder, and then we upload that file, and then it is available. Okay? You need to be cautious about the size of that folder. So, to determine the download time for a page, internet speeds, particularly bandwidth, are increasing, and this is going to be less and less of an issue. However, there are still people in this country and abroad who have access to poor internet connections, not the latest, and some people still use dial-up. Okay? If you're curious about dial-up, you might want to ask your parents about dial-up, because dial-up was a great time for internet connection. But make sure your pages are accessible to people who may have lower speeds of internet connection. Okay, that's not always possible, but you want to try and strive for that. So step one, you want to check the size of your HTML files and associated images, files, or programs. To do that, you right-click on your folder containing your website files, because everything should be stored in one folder, and select Properties. Once you select Properties, you'll be able to see the size of the folder. Next, we're going to determine the network connection. Okay, I'm going to go through this rather briefly. First is up to 56 kilobits per second, which means it can be less than that, is dial-up. 768 kilobits per second to 6 megabits per second. I'm going to be correcting myself quite a few times here because there's a difference. Is DSL. 400 kilobytes per second to 2 megabits per second is satellite. 50 kilobits per second to 1.5 megabits per second is 3G. 1 megabit per second to 1 gigabit per second is cable. Up to 120 megabits per second is WiMAX broadband. This is broadband connections. Up to 1 gigabit, gotta correct myself, you'll see why, Gigabit per second is fiber. That's considered the more standard right now, and what we're trying to aim for is more fiber connections because it's extremely fast. And then up to 12 megabits per second is 4G LTE. 5G will be more than that. Okay, 5G is gonna be approaching the gigabit per second. All right. The speed and the file size must be converted into a common unit. Okay. So, for example, and it needs to be in bytes or bits. That's why I kept saying megabits per second. Okay. Okay. Let's say, for example, and here's the main conversion that you need to know. 1 byte equals 8 bits. Okay. Connection speed for 6 megabits per second is 6 million bits per second. All you're doing is moving the decimal over. If you don't know how to do this, you can use Google, and Google will translate this for you and convert it for you, okay? But we want to get it in bits and bytes. To convert a file size into bits, convert it into bytes first. So let's say your file size of everything is 1.46 megabytes, okay? Okay, it's going to be 1,460,000 bytes first, okay? So see what I did here. I took my file size, which is 1.46 megabytes, and it's 1,460,000 bytes, okay? Converted it, moved the decimal point over. Again, Google will translate it and convert it for you. Then we're going to convert it from bytes to bits because 1 byte equals 8 bits, okay? We multiply 1,460,000 by 8, and that gives us 11,680,000 bits, okay? So we now have 11,680,000 bits, and that's our file size, okay? You're going to divide the file size by the connection speed. We're going to use the connection speed of 6 million bits per second. The bits cancel each other out. 11,680,000 divided by 6 million. You can cross out these zeros. That will make your life easier. The bits cancel each other out, and it's 1.947, or roughly 2 seconds to download the page. Okay. You're going to need to know these conversions. I'll post the instructions for this again on our website so that you have access to that, because today's exercise is going to require you to do some conversion. There's only 4 problems, so don't worry about it. Okay, it's just for practice. Because the reason why it's for practice is because of the fact that these are theoretical. Okay, internet speeds fluctuate all the time. Okay. Connection speeds may differ, as you saw in the example when I was talking about the different types of connections. You saw there's a range, okay? That is like minimum and maximum. That's not always guaranteed, okay? It's going to depend on noisy phone lines, like if they have dial-up, and it's going to depend on network congestion, okay? Especially during our current situation. A lot more people are going online. You may have noticed that sometimes things have slowed down just a little bit, okay? And that happens. We're getting better with network congestion though, but it still happens, okay? Especially if there's a bunch of people trying to access the same resource at the same time. But the best way to get your speed tested in real world settings, like if you know users are going to be using dial-up, go find someone who has dial-up and ask if you can test it, or set up your own connection with dial-up and see if it'll work, okay? It's always important to test. All right, I'm going to post the conversion sheet for you to help you out with that, but that's going to end this lesson for today.